moving on to the next topic, which is the insertion sort. So up until now, we've been looking at different ways of storing data. We looked at the theta-n with the list, log n with the tree, and went even better. We got the almost constant time for certain classes of data with the hash table. Now, the sorts are another class of algorithms that are pretty interesting. The first one we looked at was the insertion sort. And that worked by dividing the list into two parts, a sorted part and an unsorted part. Now, on each step, we take one item out of the unsorted part of the list and put it into the sorted part of the list. The question that we have to answer was to check whether or not we understood that process. So we had a set of numbers, and the original sequence of the numbers were (31), 71, 23,
73, 29, 31, 79.
91, 79.
Where did I do it?
Somebody name was more like lessons.
I have a spare.
53, 47. Alright, now at the beginning of the sort, the entire list is unsorted. Right? So we can say that's the unsorted portion. And in front of that is the sorted portion at the start. Now on pass one, we then move one thing into the sorted list simply by having our algorithm logically partition the list. So the first thing now will be the sorted list, but it's by itself, it must be sorted. Different color marker as my partition. So this black line partitions my sorted and unsorted list. On the next step, then center one is going to move to the sorted list. Now the key is each item you inserted in the sorted list will go in the correct place. So 31, 71. Sorry, in the correct place already. So I don't need to do any shuffling there. So I have 23, 73, 29, 91, 79, 3. Pass 3. One more thing goes over. So 23 goes over. So now that 23 is in the sorted list, where do you expect it? Right in front of everything else. So our sorted list is now 23, 31, 71. And the process continues. 29 comes over. So I have 23 comes over and it must be inserted in the correct position. Seven. $79 will come over, we'll end up right after 73.
There you go.
Three is the one coming over, so 53 would be before the 71. Seven is coming over, we'll end up before the 53. So now there's only one thing left in our unsorted list. And on the next step, our unsorted list will end up empty, and that's when the algorithm concludes.
23, 29, 31, 37, 47, 53, 79, 73, 79, 91.